Hello everyone, thank you for attending this talk. I'm Srishti Palani, a PhD student at the University of California, San Diego, and this is work I did last summer at Microsoft Research with my co-authors Adam Forney, Shane Williams, Kevin Larson, Irina Spiridonova, and Mary Morris. This paper is about what eye tracking and search log data can tell us about how dyslexia impacts web search. Search engines are used by millions of people every day to accomplish a variety of tasks. Most of the pages we encounter are like these ones I found searching recently. Notice how information-rich these search engine results and web pages are. However, it is really challenging for 15% of the world's English-speaking population that has dyslexia to process the information on these pages. Having dyslexia impacts reading, writing, and spelling, despite having completely normal intelligence. This makes the commonplace task of using search engines really challenging. Prior research analyzing search log and self-report data demonstrate that using a web search engine is more difficult for people with dyslexia than those without. People with dyslexia report struggling with generating and refining keywords, determining which results to open on the search results page, and making sense of even sought after content. In this study, we aim to build on this body of knowledge by capturing the eye gaze patterns of searchers with and without dyslexia as they formulate queries, triage the results, and extract information. All of this is done using while the searchers are using Bing, which is a modern English language interactive search engine. Our research questions ask if there are any differences between the gaze patterns of searchers with and without dyslexia. And if there are, what do these differences reveal about the challenges faced and strategies used by the searchers in these two search groups? To address these research questions, we designed a study that captures the eye gaze patterns, search logs, and the self-reported experience of people as they use Bing. When each participant arrives in the research lab, the experimenter reviews the entire study procedure with the participant and proceeds to calibrate the eye tracker for them. Then participants are asked to complete 6 search tasks. For each task, they're given about 10 minutes. During this time, the experimenter reads out the backstory of the search task out loud. An example search task is, you recently watched a show on the Discovery Channel about fish that can live so deep in the ocean that they're in darkness most of the time. This made you more curious about the deepest point in the ocean. What is the name of the deepest point in the ocean bed? Once they were done searching for the search task, the experimenter then administers an oral version of the NASA Task Load Index and asks them about their prior domain experience, which is how much did they know about this coming in, and asks them about their experiences, any particular challenges faced when doing the task, or any strategies used. All of the instructions are given verbally so that reading difficulties do not impact the understanding of tasks, as well as to avoid giving participants clues regarding the spelling of search queries. The study was divided into 3 phases. Across each phase, we focused on a different stage of the information search process. This is an example of one of the tasks in phase 1, where we asked them to understand how are the ATP rankings determined. Here you can see the searcher composing a query, looking at the search bar and the autocomplete suggestions. This is an instrumented view of the participants' eyes being tracked. This view is not what participants interacted with. It was more for the research team to view. Here you can see the eyes reading currently the snippet of the first search result, and then they're moving to the title of the second search result, clicking that, and going to the particular web page. As I mentioned before, each phase in the study looks at a different phase in the information search process. In phase 1, like in the search task we just saw, we let people formulate and reformulate as many queries as they wanted, because here we were focused on analyzing the different query formulation patterns. However, in the second and third phases, particularly, we controlled for query formulation because, for example, in the second phase, we were focused on the search results triage particularly. So we control for query formulation by presenting a pre-populated search results page with a fixed query and observe how people choose which parts of the search results page are more relevant to answer the task. They can do this by opening a link or by just reading snippets on the results page. They don't have to open any links. In the third phase, we are interested in how people extract information from the results. So in that case, we present them again with a pre-populated search results page for the fixed query like we did in phase 2. But here we ask them to open at least 3 web pages from the search results page, hoping that there's an overlap in many participants looking at particular web pages, which will allow us to compare information extraction behavior from web pages. We recruited participants using paid social media ads and by reaching out to organizations related to dyslexia, including a special education secondary school. Half of the recruited participants had a medical diagnosis of dyslexia. They were fairly balanced across age groups as teenagers and adults. 9 of the participants were male, while 18 were female. For our apparatus, we used the Tobii 4C eye tracker with the license for data recording and instrumented a browser extension which let us see what exactly they were looking at on the screen. Before we delve into our exciting results, I just want to note that there are a lot more results that we report in the paper, but in the interest of time, I'll go through and highlight just a few. Please go read our paper to learn more about the results as well as the design insights from these findings to make search more cognitively accessible, especially for those with dyslexia. Okay, looking at the search logs, we see that during query formulation, searchers with dyslexia issue more queries and make more errors per query, particularly at the phonetic level as opposed to the typographic level than when compared to the control group. Here, an example of a phonetic error is in spelling the word deepest, instead of using a double E, using an I, which is a difference in spelling while the phoneme E remains the same for deepest. These results match what we would have expected given that there is a large body of research saying that searchers with dyslexia have trouble spelling, especially at the phonetic level. When triaging search results, searchers with dyslexia came back to look at the same search results page more times and inspected more results than the control group. They might revisit and reread information because dyslexia is associated in literature with having a shorter working memory. Since in our experimental setup without scrolling, the search browser shows only 3 to 4 results. This result that searchers with dyslexia on average look at over 7 results means that searchers with dyslexia scroll further down the search engine results page than the control group to find possibly less relevant results. This result here is in agreement with previous literature that suggests that searchers with dyslexia might have more difficulty eliminating irrelevant results on the search results page. Okay, now going into the exciting eye tracking results. Searchers, when looking at the differences in eye gaze patterns in the eye tracking logs, we classified the eye gaze patterns into 4 particular types. The first type is the commitment fixation pattern on the left. Here, searchers fixate on all or most of the content on the page. This pattern demonstrates traditional reading and not scanning. This is the most effective for reading comprehension. Here, in the image in black, you see the page outlines of the different page elements, and in red, you see the different fixations where the participant's eyes stop to process information. Here you see that the red marks in the commitment fixation pattern are almost covering all of the body of the page. On the other hand, you see in the F-shaped pattern, the fixation red dots are similar to the letter F. Text on the left and towards the top of the page is read more than text on the right or on the bottom of the page. Third type of fixation pattern is the layer cake pattern. It's very similar to the F-shaped pattern, but here the fixations are really centered on the headings and subheadings. Searchers go from heading to heading until they locate the heading or part of the page that they're interested in. At that point, there are a lot of fixations in that particular part. It is the most effective scanning pattern. And lastly, we have the spotted scanning pattern, which involves fixating on specific words or parts of the page. Searchers might choose these spots because either it stands out with bold and large text, or because word shapes particularly might resemble words that they're looking for to answer that task. Looking at how searchers with dyslexia and without dyslexia examine a search engine results page, we find that searchers with dyslexia mostly use the commitment scanning pattern for examining a search results page. They're very thorough and exhaustive in carefully reading the entire search engine results page. On the other hand, the control group, that is the searchers without dyslexia, use an F-shaped pattern, which indicates a quick scanning of the search engine results page based on titles and focusing mostly on the top left corner. We further analyzed the eye tracking logs to see if there were particular page elements that searchers with dyslexia fixated on for more time. We found that searchers with dyslexia paid more visual attention to the entire page compared to searchers without dyslexia. They fixated for significantly longer on instant answers, ad results, as well as organic search results, and even the related searchers. This might be because they examined the search engine results page more exhaustively using the commitment fixation pattern. These results help explain prior findings that report that searchers with dyslexia struggle with search results triage. While we expected searchers with dyslexia to pay more visual attention to bold fonts and images than the control group, because they often, literature says that they help make a page more readable, we did not find any significant differences. However, when we asked the participants in the post-task questionnaire, they said that they do rely on these features, or maybe just not significantly different than the control group. The results that we get from the scanning patterns used during when examining a web page is very similar to how searchers examined the search engine results page. Searchers with dyslexia mostly use commitment scanning pattern, whereas searchers without dyslexia mostly use an F-shaped pattern. Furthermore, these results confirm that searchers with dyslexia exhibit different gaze patterns than the control group, and that this might indicate searchers with dyslexia struggle with information extraction. There are many opportunities for future work, particularly for the first is we did not allow searchers to use any assistive technology or change any of the default display settings of the browser. While this helped us control the visual interface and compare across many different participants, at least 2 of our participants mentioned that they often use additional assistive aids for increasing the readability, for example, by zooming particular parts. In future work, we would like to evaluate the impact of searchers with dyslexia using different aids during web search. Second, in this study, we examined fixations, which is how long your eyes rest on a point to process the information. Fixations paint a very detailed picture, as we just saw in our results. However, in the future, we are curious to know, to study the saccadic patterns, which is how the eyes rapidly move between 2 fixation points. Lastly, for our study, we ensured that all participants with dyslexia had a medical diagnosis of dyslexia. However, dyslexia is a spectrum disorder. And in the future, we would like to study how different subsets of dyslexia symptoms impact web search. In conclusion, this paper is the first to present findings from gaze data collected from English-speaking searchers with and without dyslexia, using a modern interactive search engine and looking at the entire search process: query formulation, search results triage, and information extraction from web pages. The gaze patterns and search behavior demonstrate that searchers with dyslexia have more spelling errors, particularly phonetic errors during query formulation. They look further down the search engine results page and use less efficient scanning patterns than searchers in the control group. There are a lot more results that we report in the paper, and we also share design insights for improving web search for people with dyslexia based on our findings. Please go read our paper available here at this link at aka.ms/dyslexia SIGIR to know more about how to improve the cognitive accessibility of search engines and web documents. Thank you. I look forward to your questions and feedback.